This week we have been looking at anomaly detection for intrusion detection systems. And generally we built models using both supervised and unsupervised machine learning, compared the performance of this model to see which model is best in anomaly detection. So we built 7 models. The first being random forest and supervised, and then we tuned the random forest to come up with a tuned model. We also did isolation forest and then tuned isolation forest for supervised learning, and also did one class support vector machine and supervised. Then on supervised, we also used support vector classifier and tuned support vector classifier. So we compared the performance, and you can see from the performance in the test, in the train and test. And in summary, the performance, we built the 7 models with scorer metrics being area under curve, since it measures ability of the model to distinguish between positives and negative class across all possible ratios. Based on this metric, random forest tuned had the best performance on validation at 79.61, followed by random forest base at 71, and support vector classifier tuned at 67, followed by support vector classifier base at 63. Then one class support vector machine at 61%, followed by isolation forest tuned at 61, and finally isolation forest-based model at 50%. However, based on generalization, the model's random forest tuned, random forest based, support vector classifier tuned, support vector based, one class support vector machine, isolation forest based did not generalize well, as the models were overfitting due to high variations between various metrics in validation and test dataset. Then the model isolation forest tuned seems to generalize well with no overfitting. Hence, it was chosen as the best model with performance at 61.8%. And based on all this, we can see isolation forest model was best in anomaly detection. Thank you.